Thanks for the introduction, Matt. I'm Bill Blankenship, Director of Sales and Engineering for Layton Systems. And today I'm going to be discussing what is predictive maintenance and how to get started in it. Layton Systems, as Matt mentioned, we're a food processing equipment manufacturer. And so we have a lot of experience in how to keep our equipment running. What is predictive maintenance, though? We get that question quite frequently. And what it basically is just the gathering and use of information uh, to know when maintenance and repairs are needed so issues can be handled before a breakdown occurs. What customers want is they don't want their equipment to break down unexpectedly, especially at the worst time, which is usually when you're making your most important run. But basically, what is predictive maintenance? It's really try to fix it before it fails. So, what are the benefits to people? Why should you do predictive maintenance? Well, from an equipment manufacturer, keeps the equipment running efficiently. Just there's just less breakdowns. It's like on a car, taking it in for oil changes, having your brakes serviced, doing all the things you're supposed to do to a piece of equipment just makes it run. When it gives you a signal that there's something isn't right, you take it into the shop to have it repaired. Equipment in your plant is no different. Sometimes it doesn't have all those bells and whistles that you might see in your car, but if you monitor certain key things about your equipment, you're definitely on the right road to what predictive maintenance is all about. It's basically helping to plan maintenance tasks and to increase the service life of the equipment and to keep it running when you need it most. So, what I would usually ask customers is, what does it cost for an hour of downtime during your most critical production runs? What we want to know is that's kind of a gauge as to how much you can afford to spend on predictive maintenance, because that's what you're trying to avoid is not only the loss of the production time, possibly the loss of product, and the image it presents to the customers you're trying to deliver to. One way to think about predictive maintenance, it's like getting a yearly physical for yourself. Once a year, you're supposed to go into the doctor, check you out, make sure you're healthy, everything's good. Um, Predictive maintenance is very much a similar animal. It's just like that. What you want to do is you want to go in and you want to look at your equipment like a doctor would a person. You want to measure certain key features and get indications that it's working okay. You're looking for what is the sign or the health of the equipment. Is it running well? Just like you want a good physical, you want a good inspection of your equipment on a regular basis. And basically, what it is basically like the doctor, he's taking measurements of key things around your body: temperature, weight, reflexes, and you're doing the same thing with equipment, just like a doctor would. So, if you kind of use that as a way of trying to understand predictive maintenance, what you would want to do is on the left here in my slide, you'll see kind of what a human doctor would do for a physical, and what we do on the other side that's related to predictive maintenance. So, doctors use tests and tools to get a sense of what your health is. We use sensors, diagnostic monitors. We monitor temperature, pressure to get that. What we're trying to do is the doctor is trying to detect signs of an illness before it becomes an unfortunate event in your life that like cancer. From the viewpoint of machine health, we're trying to look for early signs of a component failure before it becomes catastrophic and something happens. The doctor will take preventative steps, changing your medications, lifestyle changes. We do the same thing, but what we call that is preventative maintenance, such as lubricating parts, cleaning equipment, making sure everything is working well. But ultimately, the same thing in both cases is what we're trying to get at. From a human point of view, you're trying to avoid um, uh, being stuck in a hospital. from something that happens. Whereas on the machine side, we're trying to avoid the breakdowns and unplanned downtime. So a lot of people say now, well, this sounds complicated. How do I get started? Actually, it's really simple. We look at if you want to get started, there's really about three things on in almost any piece of equipment that you want to look at. What you want to do is we would recommend starting with three things: power consumption, how much is it consuming? Because it can be an indication of a problem with the piece of equipment if it starts consuming more power. We look for areas that might be an increase in heat. What we're looking for there is areas that might have more resistance, something that is harder to run, causing heat. We look for noise and movement, things that look odd, things that don't sound correctly. And again, you can kind of relate all this to your yearly physical, in a sense, or how everyone lives. Is power consumption. Well, if your energy is down and you need more rest, that might be a sign that something's wrong. If you have a temperature, could indicate you have a fever. You might be sick. Noises or movements. As I know, as I get older, I get more creaky, harder to get started. Same things can happen to machines. It's very, very similar kind of situation. So then what do you do? Well, it's very basic. If anyone can spare 5 minutes, anyone can do a quick assessment of almost any machine, just with a few common tools and a little bit of time just looking around. What you want to do, we recommend first check the power on a piece of equipment. Power is a good indication uh, of if there's an issue. For instance, with an electric motor, if an ohm motor starts to draw more amperage, it can be a sign that it's working harder. That's not good. Why is it working harder? Is it because something's wrong with the motor? Maybe there's something wrong with something else, like a bad bearing, for instance. But if you just monitor that, just like shown in the picture there, it's a very good reading of what might be going on. You can take a temperature from pieces of equipment, just walking around, measuring temperature on various surfaces. Does it appear to be hot? Most things should run pretty cool on a machine when it's normal. But if things are starting to wear out, have more resistance, they're going to get hotter. Um, and just taking a very basic temperature gun around to a few key areas. For me, I like to look at electric motors. I measure pumps, look at bearings. Anything that has any kind of movement associated with it is usually a good place to measure temperature at. Final is just kind of walk around. Does everything look okay? Just kind of like a doctor will listen to your heart and lungs for how things are going. What I like to do is go walk around and am I hearing any squeaks, any banging? Is anything shaking, moving oddly? I'm just looking for things that appear odd or out of place. Just trying to do an assessment. Does the piece of equipment appear to be operating like it should, or is it struggling in some way? Those are all indications of something that might be coming up as a possible failure. So once you do that, that really is a good start for just basic predictive maintenance in a very manual way. Um, and it's really nothing different than what people are probably already used to. It's just called something different, possibly for you. So if you pass the physical, now what? If everything appears normal, record it. Because it's that record that you're maintaining now. And if you do it on a regular basis, then you're going to start to see on a piece of equipment of how it's supposed to run. And if things start to change, then you're going to know about it. You're going to see it in the data that you're looking at. And this is really the start of what we call predictive maintenance, because it's that analyzing of that data, which is so important to try to understand when something is going wrong. Is there changes in temperature over time? Is the power going up? These are all things that we look for in our equipment because it's a good indication, since we're not there every day, of what might, if we record it every month, every few months, starts to give us an indication of that the machine is is still operating the same, or if it's starting to have some problems. So at this point, what's next? Well, you can just continue to do what you're doing, maybe daily, weekly, monthly. It doesn't have to be any more complex than that. It doesn't require a lot of time, doesn't require a lot of money in sophisticated equipment. Just the basics sets you up for what we would call predictive maintenance, because it's that monitoring of the information that's so important. But it can do more than just that. Um, if you start to check equipment sooner, you're going to see problems sooner. Now, how far you go, it really depends upon what your expectations for the results are. How soon do you want to see something happening, and what do you want to hear? So, if you start with the simple, that's what I like to do. Then I start to learn what I should do in a machine. I start to get to know the machine. I start to look at the areas that I should be looking at. And then I start to think, well, maybe I'll start to ask manufacturer of the machine. What are the areas they may be looking at? I read the manuals. Maybe they have suggestions for other areas that might work as well. Things like actuators, pneumatic pressure, for us in vibratory equipment, we like to monitor the stroke. Might look at things if we have data coming from a control system, maybe loss of product or speeds. Anything like that that you might want to monitor can certainly be added to a predictive maintenance. How far you take it, it's totally up to you. Now, the next sort of the final step in the process then is you want to automate it. Perhaps you're running on a very lean crew and they may not have time to monitor stuff as frequently as you might need to. Well, buying today, sensors are becoming much less expensive for even just the very basics. You can start to monitor things in real time. And if you integrate them with maybe your an existing monitoring system, or possibly even set it up on a standalone PC, you can just integrate basic sensors that measure amperage, temperature, vibration. A few $1,000s, and you probably have a very robust system that's going to give you an early warning when something is happening. You can start to set up acceptable ranges for what the equipment should be monitoring in. And it can also be a system that alerts you, maybe with a light, an audible alarm. It might be as sophisticated as sending out text messages if you want to go to that extent to someone that says, hey, look at this area. But in the end, it can be automated so that the readings become continuous, real time, so that you get a much more sooner warning of an impending issue. Um, and really, at that point, you've kind of completed the start of your predictive maintenance program. You can take it from just the simple, and then you can start to expand it and automate it from there. And how far you take it in today's world, honestly, daily I get inquiries on how far do you want to go. It really just depends on how sophisticated you want the system to be. Do you want it to include AI? Do you want it to have a system dashboard that monitors every piece of equipment in the plant, or just a few? Really, it's totally open. And from there, it kind of leads us really into the next sessions we have today, where people are going to be talking about some of the specific tools that can help you automate the process.